1850, the oldest locomotive company in America rolled out a diesel that could outpull anything else on the market. 1,600 horsepower, a face like a predator on rails. Tractive effort numbers that made the best-selling diesel in the country look soft. Baldwin called it the RF-16. The men who ran them called it the Shark. It was supposed to save the company. Spoiler, it didn't. So, Baldwin Locomotive Works. If your father or your grandfather worked anywhere near the American railroad industry in the first half of the 20th century, they knew this name, not as one name among many, as the name, the biggest, the oldest, the one that mattered most. Founded in 1825 by a man named Matthias Baldwin, a Philadelphia jeweler and machinist who discovered he had a talent for building steam engines and then spent the rest of his life perfecting that talent, the company produced more than 70,000 locomotives over its long history. 70,000. That is a number worth sitting with for a moment. From the Civil War through the Gilded Age, through 2 world wars, if it ran on rails and it ran on steam, there was a very good chance that Baldwin Locomotive Works of Philadelphia, Pennsylvania, had built it. At their peak, they were turning out thousands of engines per year. They shipped not just across the United States, but to railroads on every continent that had track. South America, Africa, Asia, Europe, during the rebuilding after both wars. They were, by any reasonable measure, the most important locomotive manufacturer in the history of the world, and they knew it. That confidence would become the problem. Their factory complex at Eddystone, just outside Philadelphia in Delaware County, was a monument to that confidence. Sprawling across hundreds of acres of industrial land, it was designed from the ground up to produce more than 3,000 locomotives per year. Baldwin started buying the property in 1906, and the construction project dragged on for more than 2 decades before finally completing in 1928. The timing of that completion turned out to be one of the great cruel jokes of American industrial history. The company had stretched itself dangerously thin to build the place, pouring millions of dollars into an operation scaled for an endless boom. Then the Great Depression arrived and sales vanished almost overnight. The workforce was slashed from more than 5,000 employees down to just 610 by 1932. Westinghouse Electric, which had been Baldwin's partner in building electric and diesel-electric equipment since 1904, had to step in and buy a controlling stake in the company to keep the doors open. And here is the detail that hangs over every chapter of the rest of this story. The Eddystone plant never once operated at full capacity, not in a single year, not even during the war years when demand was high. Most estimates say it never ran at more than 1/3 of what it was designed to handle. They built an industrial palace for a kingdom that was already shrinking, and they kept waiting for the kingdom to grow back for another 3 decades. Baldwin's leadership was not just optimistic about steam power, they were ideologically committed to it. In 1930, company chairman Samuel Vauquelin gave a formal speech in which he declared publicly that advances in steam technology would ensure the dominance of the steam locomotive until at least 1980. That is not a typo. He said 1980. In 1935, Baldwin's Vice President Robert Binkard gave a speech with the remarkable title, "Muzzle not the ox that treadeth the corn." In it, he acknowledged the new diesel streamliners making headlines, but dismissed them as flashy novelties. He acknowledged the Zephyr and its kind. But the real freight work of American railroads, he assured everyone, would remain with steam for the foreseeable future. These were not casual opinions shared at a dinner party. These were strategic declarations from the top executives of the world's largest locomotive builder. They were betting their entire company on steam, and they held that bet for more than a decade while their competitors built the future without them. Meanwhile, at a factory in LaGrange, Illinois, a division of General Motors called the Electromotive Division was quietly doing exactly that. Here is where the story turns, and it turns hard. In 1939, EMD introduced the FT locomotive, a freight diesel, 1,400 horsepower in a streamlined car-body. Diesel locomotives had pulled passenger trains before this. They had switched cars in freight yards, but the FT was designed for something that no diesel had previously attempted at commercial scale: mainline freight. The hardest, heaviest, most profitable work on any American railroad. And General Motors, being General Motors, did something that no traditional locomotive builder had ever dreamed of doing. They put the FT on an 83,000-mile demonstration tour that crisscrossed the entire country. They brought it to railroad after railroad. They let the people who actually ran these railroads, the operating executives, and the mechanical officers, watch this diesel do the work of their biggest and most powerful steam engines. They demonstrated on the New York Central, on the Baltimore and Ohio, on the Erie. Western railroads were especially impressed because the FT freed them from having to supply good water for steam engines across hundreds of miles of arid desert. They conspicuously did not bring the FT to the Pennsylvania Railroad. The PRR would not allow a diesel freight locomotive on their property. Steam was a matter of institutional identity in Altoona. The 3 roads that actually witnessed the FT in action? They ordered production units immediately. The editor of Trains magazine later called the FT the diesel that did it, meaning the machine that shattered the last argument for steam dominance in freight service. Then World War II gave EMD an advantage that no competitor would ever fully overcome. The War Production Board, which controlled American wartime industrial output, restricted what each manufacturer could produce. Baldwin and Alco were told to keep building steam locomotives and diesel yard switchers. EMD received authorization to mass-produce FT freight diesels. For the entire duration of the war, EMD was building, refining, testing, and perfecting mainline diesel production at scale. Training workers, optimizing supply chains, building institutional knowledge. Meanwhile, in some cases, railroads actually wanted to buy diesels from EMD during the war, but the War Production Board prevented them, directing them to buy modern steam locomotives from Baldwin and Alco instead. So Baldwin was building machines that their own customers didn't want under government orders, while EMD built the machines that everyone did want. By the time the war ended in '45, EMD had accumulated more than a decade of diesel experience. They had a proven product, an efficient factory, and the General Motors Corporation behind them for parts, financing, marketing, and field support. Baldwin had none of those things. By 1948, demand for new steam locomotives in the United States had dropped to just 2% of the total locomotive market. A year later, it was 0. The transition happened faster than almost anyone in the industry had predicted, and it caught Baldwin completely flat-footed despite more than a decade of warning signs. The company's belated plunge into diesel production was ambitious but chaotic, and the results showed. Railroads were scrambling to modernize, orders poured in. But Baldwin approached diesel manufacturing the way they had always built steam: custom, handcrafted, one at a time. Wiring layouts varied between units of the same model. Component placement differed from locomotive to locomotive. No 2 Baldwins were exactly alike. In the steam era, that was craftsmanship. In the diesel era, where foremen needed interchangeable parts and standardized maintenance procedures, it was a disaster. EMD had brought assembly line discipline to locomotive building. Every F7 was identical, parts interchanged, procedures standardized. No one know them all. Baldwin was selling bespoke machines in a mass production market, and the market had no patience for it. The numbers told the story clearly. By the late 40s, EMD and Alco had each settled on 4 or 5 standard locomotive models that covered the full range of railroad needs: freight units, passenger units, switchers, road switchers. A manageable catalog. Baldwin, meanwhile, offered dozens of different models, many of which sold only a handful of units. This was the old steam-era approach, a different design for every customer who asked. But it meant that Baldwin never achieved economies of scale on any single model. They couldn't refine a design through thousands of production units the way EMD could. They couldn't build up a deep inventory of spare parts for any one type. Every small batch model was essentially a prototype that happened to get sold, and every prototype came with prototype-level reliability problems. Their early cab unit diesels, wearing the rounded baby face carbody, built a grim reputation. The engines were strong but unreliable, persistent piston failures, excessive oil consumption, bearing surfaces needing 8 to 16 hours of hand scraping. The Westinghouse traction motors were superb, heavy, overbuilt, packed with copper. Baldwin even leaned into this as a selling point, advertising their diesels as hauling fools. And they were. When a Baldwin was running, it pulled harder than almost anything else on the property. The problem was the when it was running part, but the prime movers driving them kept breaking. And when a Baldwin broke on some railroad's property, the part support was glacially slow. A retired New York Central purchasing man was asked why the NYC stopped ordering Baldwins. His answer was instant. They failed in product support. When we had a Baldwin in the shop awaiting materials, it sat for days, sometimes weeks. EMD did whatever it took to get their units back online, whatever the problem. Baldwin's first attempt at a serious road diesel, the Centipede, tells you everything you need to know about their approach. Built from 45 to 48, the Centipede was a massive 3,000 horsepower twin-engine monster that rode on 12 axles per unit. The nickname came from all those wheels stretching in an almost unbroken line. It was powerful. It was impressive to look at. And it was a maintenance catastrophe. Internal wiring was run through metal conduits, exactly like a steam locomotive's, which caused constant electrical problems. Only 3 railroads bought them. By the early 60s, most had been scrapped. Baldwin had tried to solve the diesel problem the Baldwin way, make it big, make it powerful, make it complicated. The market wanted something else entirely. By the late 40s, Baldwin recognized they needed more than better engines. They needed a new identity. Railroad buyers looked at a new Baldwin diesel and saw the ghost of every Baldwin that had failed them. The company needed a total visual and psychological break. They hired Hadley, Ryder, and Pedersen, an industrial design firm. The brief was clear. Create a diesel that looks like nothing Baldwin has ever built. Make it aggressive. Make it modern. Donald Hadley led the design. He studied the Pennsylvania Railroad's T-one class duplex steam locomotive, styled by Raymond Loewy. The T-one was angular, predatory, futuristic. It had its own problems. Wheel slip, high maintenance costs, a short career. But it was gorgeous, and everyone knew it. Hadley adapted that swooping angular nose for a diesel carbody. Eddystone workers took one look and christened it the Sharknose. The name stuck permanently. And here is the correction that needs repeating. This was not a Raymond Loewy design. Loewy designed the T-one that inspired it. The Sharknose was Hadley's work. U.S. design patent D-154-120 bears his name alone. The first Sharknose units were passenger locomotives delivered in 48 exclusively to the PRR. 18 A units, 9 B units, classified BP-20. The only passenger Sharks ever built. But the machine that would carry the legend was the freight version, the RF-16. If you're still with me, hit subscribe. We cover engineering stories like this every week. All right, back to it. The RF-16 was a cleaned-up version of Baldwin's earlier freight cab unit. The key change was the engine. Baldwin's 608A prime mover used an Elliott turbocharger to push output from 1,500 to 1,600 horsepower. That gave the Shark a 100-horse edge over the EMD F-7, which produced 1,500 from its 16-cylinder 567B two-stroke diesel. Alco's FA2 also made 1,600. So the Shark matched Alco and topped EMD. The designation was simple. RF meant road freight. 16 meant 1,600 horsepower. The RF-16 was the only cab unit in Baldwin's new standard line of 1950, their late attempt to standardize like EMD. But horsepower was not where the Shark distinguished itself. Continuous tractive effort was. This is the sustained pulling force that matters most in heavy freight. Depending on gear ratio, the RF-16 delivered between 42,200 and 52,500 pounds of continuous tractive effort. The F-7 managed about 40,000, a real significant gap, not a rounding error. The reason was the Westinghouse traction motors. They were physically larger than EMD's units, more copper in the windings, allowing higher sustained current, more iron in the frame, producing a stronger magnetic field. The result was considerably more torque at low speed. In practice, a Shark could grab the rail and haul a heavier train up a steeper grade at a slower pace than an F-7. The advantage faded at higher speeds, but in the service where Sharks spent their lives, low-speed pulling power was the whole game. The locomotive used a BB wheel arrangement, two two-axle trucks, all four axles powered, standard AAR Type B road trucks. About 50 feet 8 inches long, roughly 248,000 pounds. It came as cab-equipped A units and cable-less B unit boosters. Production ran from November 50 through 53. Baldwin built 109 A units and 51 B units domestically, 160 total, plus 51 export units for Argentina on broader gauge trucks for passenger service. Coal drags. That is where the Shark lived and where it earned its reputation. Long, grinding trains of loaded hoppers, sometimes 100 cars or more, crawling up Appalachian mountain grades at 5 or 10 miles per hour. No passenger service glamour, no named trains. Just raw tonnage hauled over ridgelines by brute force day after day, keeping power plants running and cities lit across the eastern seaboard. The RF-16 was built for exactly this. Those Westinghouse motors held their torque hour after hour in sustained pulling that would overheat lesser equipment. Crews who ran Sharks in coal service praised them consistently. They lugged, they gripped, they got the work done. The Pennsylvania Railroad was the largest buyer. The Baltimore and Ohio ordered a substantial fleet. The New York Central bought units. The Elgin, Joliet, and Eastern placed orders. For a moment it looked like Baldwin had a real contender, but the reality on the railroad was more complicated than the spec sheet suggested. The PRR, being Baldwin's closest customer and the railroad that had essentially commissioned the Sharknose design, gave the locomotives favorable assignments and kept their shop forces trained on Baldwin equipment. They got reasonable service life out of their units. The B&O had a similar experience, running their Sharks out of Pittsburgh toward Rochester and getting decent work from them. But on railroads where Baldwin power was a minority of the fleet, the story was different. When most of your shop tools, most of your spare parts, and most of your mechanics training is oriented toward EMD equipment, keeping a small number of Baldwins running becomes disproportionately expensive. You are essentially maintaining two separate supply chains for one railroad, and that math never works in the Baldwin's favor. But the problems were mounting faster than the sales could offset. The RF-16 used an air-powered throttle, incompatible with the electrical throttles that EMD and Alco used. Sharks could not run and consist with other makes without special adapters. In an industry standardizing around EMD systems, this meant segregating your Baldwin power from everything else on the roster. That is not flexibility. That is a scheduling headache that nobody wanted to deal with. The prime mover, though improved, carried old weaknesses. Larger cylinders than EMDs meant heavier pistons and more labor per maintenance event. The piston ring grooves were a chronic failure point. A redesigned piston finally solved the problem in 1960, 5 years after Baldwin stopped building locomotives entirely. The bed plate was well engineered, but its bearing surfaces still needed hand scraping, 8 to 16 hours per engine. EMD was stamping parts from standardized dies. Baldwin was finishing engines by hand. In the 1950s, cost was the quiet killer. A Baldwin diesel switcher cost about $105,000 to build. The equivalent EMD unit cost roughly $95,000. EMD sold at about $100,000 and made $5,000 profit per locomotive. Baldwin was breaking even at best and losing money at worst. When your competitor profits and you bleed on the same product line, volume only accelerates the collapse. Then, in 1953, came the blow from within. Westinghouse decided to exit the traction equipment business entirely. Baldwin had depended on Westinghouse electrical gear for every diesel it ever built. Now they had to rebuild around General Electric components, essentially redesigning their electrical architecture while trying to keep up with a market that was leaving them behind. The cruelest irony was the timing. Baldwin's management had finally, genuinely committed to competing in the diesel market, and their parent company killed that effort from above. Westinghouse had controlled Baldwin since the Depression-era bailout. Now they were pulling the company out of the locomotive business. The retirement of the Sharknoses across America was swift and merciless. The Baltimore and Ohio struck its entire RF-16 fleet in '62, barely a decade of service from a locomotive with a useful life expectancy of 20 years or more. The Pennsylvania Railroad, Baldwin's customer of over a century, the railroad that had purchased more Baldwin locomotives than any other institution in the history of the business, scrapped or sold every single Sharknose by '66, a commercial relationship stretching back to the age of Jackson severed. The New York Central was the last major road to run Sharks. In late '67, they sold the remaining units to the Monongahela Railway for $6,000 apiece. That is $6,000 for a locomotive that cost well over $100,000 to build less than 20 years earlier. Adjusted for inflation, roughly $58,000 today. The Monongahela ran them in coal drag service, exactly where Sharks belonged, and worked them hard for 5 years. By '72, attrition left just 2 operational survivors, numbers 1205 and 1216. They were headed for the scrap torch when the Delaware and Hudson Railway intervened, acquiring them in exchange for an equal weight of scrap steel. The D&H, a small road with a well-known soft spot for unusual motive power, ran them in freight and passenger excursion service until '78. After that, the pair passed through a leasing company called Castellite Corporation, ran briefly on the Michigan Northern Railway, and ended up in storage on the Escanaba and Lake Superior Railroad in Michigan's Upper Peninsula. They have been there since the early 1980s, locked away out of public view. The railroad's owner has promised museum donation for years. It has not happened yet. Baldwin's own end came just a few years after. In '56, the PRR decided to retire its massive steam fleet and order new diesels in bulk. Baldwin bid, counting on the loyalty of their oldest customer to extend one final lifeline. EMD offered the PRR a package deal on GP9s at a price Baldwin could not approach. The Pennsy, in its own deepening financial crisis, chose the cheaper, more reliable option. Baldwin closed the Eddystone plant that year and never built another locomotive. They had tried one last desperate measure in '51, merging with the Lima-Hamilton Corporation to form Baldwin-Lima-Hamilton, hoping the combination would give them enough scale to compete. It didn't. Lima-Hamilton's locomotive technology went unused, and market share kept shrinking. The company was sold to Armour and Company in '65, absorbed by Greyhound Corporation in '70, and dissolved entirely by '72. 125 years of continuous locomotive production, more than 70,000 machines, gone. The EMD F7, the locomotive the Sharknose was built to unseat, became the most prolific diesel of its era, close to 3,900 units produced. That is roughly 24 times the total number of RF-16s Baldwin ever sold. The F7 was not even a revolutionary design. It was simply an incremental improvement over the F3 that preceded it, with a slightly updated generator and traction motor. The genius was not in any single specification. It was in the fact that EMD had built such a strong reputation for quality and service that railroads ordered the F7 almost reflexively. Santa Fe bought over 450. Southern Pacific bought over 500. The F7 outsold every other diesel model from every other builder combined. Many ran well through the '70s. Some survived into the '80s and '90s on short lines. The F7 was not just a locomotive, it was the standard, and the Shark barely scratched its market dominance. Even as the F7 was selling by the thousands, the real future was already moving past cab units entirely. EMD's GP7 road switcher, introduced in '49, was proving that railroads wanted something more versatile than a cab unit, something that could switch yards and run on the main line. Baldwin never got a chance to compete in that market at scale. The RF-16 was not a bad locomotive. In heavy drag service at low speed, it was genuinely better than the F7. Those Westinghouse motors pulled harder, sustained longer, and gripped tighter. The crews who ran them in coal service knew it, but the locomotive was one piece of a system, and Baldwin had no system. No parts network worthy of the name, no field support infrastructure, no standardization, no throttle compatibility with the rest of the fleet. They wrapped genuine pulling power in one of the most aggressive, most memorable designs in railroad history. And none of it was enough. Baldwin sold machines. EMD sold an ecosystem, standardized parts, assembly line consistency, interchangeable components across the entire fleet. Field service engineers stationed at every major railroad facility in the country. A phone number that someone actually answered at 2 in the morning when a locomotive went down. And behind all of that stood General Motors, the largest corporation in the world, with financing programs that smaller builders could never match, and a marketing operation that treated locomotive sales like automobile sales. EMD didn't just wait for railroads to call. They sent sales teams out. They offered trade-in deals. They created financing packages. They made it easy to say yes. Baldwin offered raw capability and hoped it would be enough. EMD offered reliability, compatibility, support, and peace of mind. And when the purchasing decisions got made, year after year, railroads didn't buy horsepower. They bought the system that let them sleep at night. EMD had that. Baldwin never figured out how to build it. 2 RF-16 Sharknoses survive today in Michigan, locked away on a short line in the Upper Peninsula, waiting for a future that may never come. 3 more reportedly exist in Argentina, exported for passenger service on broader gauge track, with at least one said to have been restored to operational condition. The Eddystone factory is gone. The tooling was destroyed decades ago. The company itself was dissolved more than 50 years ago. The engineers who designed the Sharknose are gone now, and some of their knowledge went with them. The story of the Baldwin Shark gets told and retold in railroad circles because it resonates far beyond trains. It is a story about what happens when a dominant company becomes so invested in its own history that it cannot see the market changing around it. Baldwin did not fail because their engineers were incompetent. The RF-16 proved they could build a locomotive that outperformed the competition in its core mission. They failed because they did not understand that in a maturing industry, The product is only half the equation. The other half is the system you wrap around it, the parts you stock, the mechanics you train, the support you provide when things go wrong at 2 in the morning on a siding in West Virginia. But that angular, predatory nose, borrowed from a Raymond Loewy steam locomotive and reimagined for the diesel age by a designer named Donald Hadley, remains one of the most distinctive, most beloved, and most unmistakable silhouettes in the entire history of American railroading. Model train manufacturers still release new Sharknose products every few years, and they sell out. The design endures because it captured something that the EMD F7, for all its success, never quite managed. The Shark looked like what it was, a machine built to pull harder than anything else on the railroad. It just came from a company that could not pull itself into the future. The Shark could outpull the competition. It just couldn't outrun the future. And in the locomotive business, those turned out to be two very different things. And there you have it, the Baldwin Sharknose. Still can't believe they sold them for $6,000 each. If you enjoyed this, subscribe. More coming soon.